So we have a really exciting three-part agenda ahead. Firstly, an update, particularly for those of you who are not familiar with the network. And I know we have those here today, both existing partners and those who haven't yet been involved in activities. So we'll just give an overview of the breadth and range of activities that we've been undertaking, including contributions from some of our academic co-investigator team. Secondly, we will hear from project leads from 4 really interesting projects funded and supported by the network, which cover a whole range of different areas in relation to transport and air quality. And we'll have an opportunity then to explore those when we move out into breakout groups at a later stage. There will be a 5-minute comfort break, appreciating the screen time as well in the meeting. Next slide. And finally, importantly, will be the opportunity for you to contribute and shape direction and next steps for where we take the findings from these projects and how we utilize those, hopefully to inform best practice and also advance the research agenda as part of the Clean Air programme, which I'll say a few words about shortly. Also really pleased that we'll be joined by one of the UK Clean Air champions, Dr. Gary Fuller, who'll be here to say some words at the end and bring together what we've heard today in the context of clean air research in the UK. Next slide. So the Transition Clean Air Network is a £500,000 investment from the Natural Environment Research Council as part of the second wave of the UK Strategic Priorities Fund. And the vision for this programme as a whole was to build interdisciplinary research and innovation that really effectively aligned with government department research priorities and needs, and had the flexibility to be able to respond appropriately to priorities and opportunities. So Transition was conceived really in the context of the drive to achieve a net zero transport system and all of the challenges and opportunities that generates. So our core focus is optimizing both air quality and health benefits in the context of those net zero targets ahead. And importantly, as will be reflected today in the presentations, our focus is not just on indoor outdoor air quality, but across that indoor and outdoor interface, recognizing that of course people experience pollutant exposure in both indoor and outdoor environments, and they move between this continuum. I think it's really important we hold that thought as we move through the meeting. Next slide. So our key questions, and these were framed really at the outset of our network, which was all pre-COVID era, back in early 2020, January 2020. We really wanted to think about the recognition that no solution to clean air is going to come either from a particular discipline or from a particular sector as a whole, and that we need to work together in a very multidisciplinary sense in order to achieve solutions and be solutions focused. The areas that we have focused upon include choices, so the way people make their choices and the importance of supporting that with social science-led research, technology and innovation to generate those necessary technical solutions, but also importantly the policy context in which these operate. And it's really that intersect between choices, technology and policy where we want to focus our efforts in our network activities. Next slide. So again, reflecting this breadth, we have 4 network themes that run throughout. Characterizing challenges and risks, and that was very much a focus of our launch workshop back in November 2020 at the start of the network. Horizon scanning and identifying what is the potential risks of decarbonisation and where can we essentially intervene to optimise air quality benefits. Transport choices and behaviours, I've already mentioned, really, really important that we don't forget people. I'm a public health physician, so I would always say that and emphasise it. Supporting industry-led research and innovation, which again is a key focus today. We want to support commercial and academic partners working together. And generating that framework and influencing and shaping the policy agenda and debate ahead. Next slide. So I won't be able to introduce everyone in the network today, but you will hear from some of our academic team, and really just to acknowledge the breadth that we span 9 UK universities and UK Health Security Agency in terms of our representation. And we have a whole range of disciplines represented here, spanning atmospheric science, emissions, social science, as well as policy and working with stakeholders and knowledge mobilization and exchange. Next slide. And we wouldn't be doing anything without our network partners. So we have over 20 partners who are a part of the network, and a wide, I should say, a much broader array of those who've been involved in different activities. But importantly, these partners span not just the academic sector, but public sector, commercial partners, as well as importantly, local authorities and those operating at a national level as well. And we're pleased that many of those partners are represented here today, and we're always very, very pleased to welcome new partners into the network as well. Next slide. So just a few examples of our collaborative activities that we've undertaken over the last 18 months. It's all gone very quickly. We're now, as I said, halfway through, but just a few highlights here. So one of our pieces of work was actually a collaboration within the Strategic Priorities Fund programme, where we linked up with an early Wave 1 project. We're a Wave 2 network, but we wanted to work with another team to explore the COVID carbon clean air trilemma with colleagues at the University of Surrey, who are focusing on unintended consequences of policy decisions for air quality. And we're pleased to have recently submitted an article arising from that work, and a policy brief will follow. We've also been working with one of our sister networks. So there are 6 of clean air networks, of which transition is just one, but the BioAir network led by Professor Fred Coulon at Cranfield University. We are undertaking scoping work at the moment on with a focus on bioaerosol transmission, of course, right at the top of the policy agenda now in the context of COVID transmission, particularly in public transport environments. And just another example of working with the commercial sector, an event we held with Breathe with Create Streets, a design consultancy, exploring the implications of the planning white paper for spatial and urban planning and upstream influences upon air quality, which again led to a policy brief informing, hopefully, the planning white paper as it potentially moves forward as well. Next slide. So all of the information from these is available on our website, and the links will be here. As I said already, we will be releasing a recording of the network, so please don't feel you've missed out already, because you will be able to revisit these activities as well. Slide. Engagement is again a core focus of the Clean Air programme as a whole, and certainly of Transition Clean Air Network. We feel it's really important to be talking to the wider general public and diverse audiences, and communicating what we're doing, communicating the findings of our projects. And this has been done through a set of quarterly webinars, notably exploring the implications of COVID, and we'll hear more about that in one of the presentations today. Microplastics as a challenge for people and the planet, held in collaboration with the University of Birmingham Institute for Global Innovation, and exploring in-vehicle air quality at our Clean Air Day webinar held in June last year. Again, all of these recordings, we should have the links here, will be made available, or are available, on the Transition Clean Air Network website. Next slide. And we had a presence at COP26, really important, we felt, to be there, to be present, particularly on Transport Day. We were part of the response to the Transport Declaration, which was made at the meeting, and also contributed to a wide range of activities, both in the green zone and the blue zone at COP26. And you'll see here as well we had a delegation visit the Hydroflex project from the University of Birmingham, which was all very, very exciting, but importantly, I think, with regard to who we're talking to and where we're talking to them and where we're taking our messages from the network as well. Next slide. And just to signpost a couple of events that are coming up very soon, we will be holding a webinar exploring barriers to active travel in local government on the 10th of March, welcoming the new West Midlands Cycling and Walking Commissioner, Adam Tranter. And also we have in the pipeline a Clean Air Zone focused event on Clean Air Day this year, which you'll hear more about from Francis Pope. So now I'm really pleased to hand over to one of our academic co-investigators, Charlotte Lander-Cox, who is an environmental health scientist at the UK Health Security Agency and of course a member of our network team. Over to you, Charlotte.
Thank you very much, Suzanne, and I'm very pleased to be talking to you today about knowledge mobilisation and our planned outputs for this Clean Air network in 2022. So we will begin with the briefing notes. We are publishing 7 briefing notes between spring and autumn this year, and they will be 4 sides of A4 paper, so very short, but very succinct, and they will be presented in the template being shown on the slide. These will be peer-reviewed, evidence-based briefing notes, identifying key messages, gaps in knowledge, and recommendations for targeted audiences. So to start in spring, we will be publishing exposure via different transport modes, which is building on the paper published last year by Dr. Christina Mitsaku. Christina presented her findings in our Clean Air Day webinar titled, "What Do We Know About In-Vehicle Air Quality?" which, as Suzanne has mentioned, is still available to listen to on the Transition Clean Air Network website and can be found under the Events tab. The audience for this briefing note will be local authorities and members of the public. The other briefing note will be barriers to active travel, which will focus on organisational barriers and mechanisms to overcome these. It's being written with colleagues in the Office of Health Improvement and Disparities, OHID, with contributions from local authorities who are the target audience. The final spring briefing note will be a non-exhaust emissions, and that's going to be directed at local authorities and government departments. We then move to the summer, and then we will have released the Transport Hubs briefing note. And this will be published and is focused on train and bus stations. It's targeted at local government. And if anyone has any case studies they would like to contribute to the briefing note, we would encourage you to contact us. The other note to be launched in the summer will be the Planning for Clean Air and Public Health, and is aimed at national government and discusses the blog that Suzanne has mentioned already. And then finally in autumn, the final 2 briefing notes, mobility and freight emissions, will be published. Mobility will focus on e-bikes, but they may be, we will also include other types of scooters too. And its target audience will be the all-party parliamentary group for cycling and walking and the health sectors. The target audience for freight emissions will be primarily government, but will include rail and road. So these briefing notes, when they are published, will be published on the Transition Clean Air Network website and also in our monthly newsletter. So if you're not already subscribed, you can register on the home page of the website. And this will not only provide you with a monthly update on the network, but also the topic of surface transport decarbonisation. And to accompany the briefing notes being published, we are holding 3 webinars throughout this year. The first one would be on our Barriers to Active Travel webinar, which is on the 10th of March, and the speaker details will be uploaded shortly onto the website, and this is where you'll be able to register to attend. We would really appreciate it if you could share details of these webinars to colleagues and other networks. And the other dates are also on the website. However, the June date may change due to the planned activities on Clean Air Day. So I've obviously, this is just an introduction to the briefing notes, but if anybody has any queries or wish to discuss these briefing notes further, please email the Transition Clean Air Network email address that can be found on the homepage on our website, and they will let me know and I will be back in contact with you. So thank you very much for your attention. And it is now my pleasure to hand over to Professor Francis Pope, who is an academic co-investigator and will be talking to you about clean air challenges and solutions.
Brilliant. Thanks a lot, Charlotte, and welcome to everyone. So I'm Francis. It's nice to talk to you today. So as Charlotte says, we've got these clean air challenges and solutions. So the network, the Transition Clean Air Network, is planning a series of events over the next 2 years, and we're very keen to get involvement from outside of the network. The idea of the network is to continue expanding. So very, very much hoping for people to input ideas as we go along. So please feel free to put something into the chat box or email us later, etc. So we've got various events coming up. The first one, which I'll talk about in detail in the next few slides, is Beyond the Clean Air Zone event, or Beyond the CAZ event, and that will coincide with Clean Air Day on the 16th of June this year. We hope to be presenting at the CENIX LCV event in September 2022, which I'm sure some of you will be at anyway. And we've got various other events planned for 2023. I won't go into today, but again, if you've got any ideas where you think this network can help you, then please do get in contact. Next slide, please. So this first event is Beyond the Clean Air Zone, or Beyond the CAZ. As I say, it's to coincide with Clean Air Day. And this is a nice graphic I found from the New York Times from last year or a couple of years ago. And so essentially in the UK and most of Europe, there's been a fairly standard version of the Clean Air Zone, which uses the Euro class as the threshold for whether you have to pay or not coming into the Clean Air Zone. But obviously there's lots of ways you could set up a Clean Air Zone. And so this day we'll think about how we might go forward with clean air zones. Essentially, do we want to get rid of them as soon as they've achieved their NOx goals, reducing nitrogen oxides, or should they be used more as a carrot or a stick to further improve emissions, whether that's through air pollution or climate emissions? So there's lots of ways you could do it. The UK has been fairly staid, I would say, in how they've done it, and maybe we could do something more exciting as a teaser. Next slide, please. So the event will be at Birmingham Central Library, which is this gold and silver building here. So it's a nice, easy walk from Birmingham New Street. So about a 5-minute walk from Birmingham New Street. So we hope to see many people there. We've had interest and confirmation from various organizations and NGOs, etc. In particular, we've been talking to Sustrans, we've been talking to UK 100, we've been talking to the Clean Air Fund, and we've been talking to the British Lung Foundation. So we hope we'll have representation from them there. Again, other organizations are very welcome. So again, if you'd like to be involved more closely with the event, please do get in contact, or if you'd just like to be an attendee, likewise, please do get in contact and watch our website for further information. Next slide, please. And so the itinerary is still tentative, but what we hope is there will be a political roundtable. And so there's lots of clean air zones either already operational, so whether it's the one in Birmingham, which started in June last year. So it'd be essentially on the 1-year anniversary of the Birmingham CAZ, or the one in London, which has been going on for longer, but has gone through an iteration or two during its lifetime and expanded further and further. There's also the one in Bath, but we know there's also been clean air zones which haven't happened, and that's interesting as well. So whether that's Leeds or Coventry, we know the Manchester one is currently under discussion. So there's a political roundtable. There will be an implementation session. So this will be more focused towards the clean air officers and the environmental officers at the council and the advice that they need from partnering organisations. There will, of course, be coffee. So coffee is good, but the networking is even better. So lots of opportunities there for that. There'll be a science session, so you'll get the latest science from the various universities involved in the network, but also from further afield. Again, if you're interested, let us know. And then we'll move more into the meat of it. So what happens after a clean air zone? How do we further advance them? What's the end goal? Do we hope to lose them ultimately, or do we use them ever more, for example? So there'll be breakout rooms to explore these questions. And then those ideas will be brought back into a plenary session. And then the final session will be to bring in the citizen groups. And I think this is to keep us honest. So what do citizens want? Why are we having clean air zones? And so that's essentially to make sure that we don't get too academic, we don't get too policy driven, we actually make sure that these clean air zones are working for the population. And then there'll be wrap up, etc. So I think that's my last slide. I never quite know until it happens, but if you go to the next slide, please. And yep, so exactly. Yep, so I'd now like to introduce Dr. James Levine, who will tell us about the clean air discovery and innovation aspects of the project. Please, James.
Thank you very much, Francis. Yes, I'm Innovation Network Manager for Transition, which has had the pleasure of funding 5 discovery and innovation research projects in pursuit of clean air solutions, spanning sectors, commercial, academic, local authority partners. 4 of these projects are now complete and showcased today. Just to flag that we will be launching a second round of the Discovery and Innovation Fund later this year in the summer. The 4 projects we focus on today touch on emissions, the identification of sources of emissions, and some of the changes in drivers of the quantity of emissions. We also look at exposure, comparative exposure in different transport modes, and starting to look at how we can minimize exposure in some priority environments, in this case, at the roadside. In a moment, we're going to start having the lead of each project give an 8 to 10 minute presentation with very short Q&A in between these presentations. So if you have questions, please pop them in the chat and I'll relay them to the lead. So without further ado, I'd like to introduce Nick Molden, founder and CEO of Emissions Analytics, to talk about their project, Measuring Exposure in Different Transport Modes. Over to you, Nick.
Great, thanks, James. Just check, can you hear me okay?
Yeah, we can hear you well. Thank you, Nick.
Fantastic, great, and thank you for the intro. Yes, so I'm going to press on pretty rapidly because I know time is tight. So James, if you wouldn't mind, actually you can flip 2 slides further on. Yeah, thank you. So yes, the background, what we're trying to achieve here is to get an idea at quite a specific level in terms of pollutants about what the human exposure is against different transport modes. And we set up a journey essentially between London, Paddington and Oxford city centre and compared different public and private transport and added in some active travel as well into that. The type of pollution we were looking at specifically was particles, including ultrafine particles, so below PM 2.5 down to 15 nanometers in reality. Also speciated VOCs, not just total VOCs, and also CO2 as a good proxy for freshness of air. And the idea was to get some quantitative information that could be used in policy. Next slide, please. And again. So to summarize this did just give you a visual. So we did 2 different train journeys. One was the diesel train straight from Paddington to Oxford. The other was electric train the underground to Waterloo, electric train to Basingstoke, and then diesel train into Oxford, using then different diesel buses to get from the station to the city centre, cycling, walking as an alternative to the city centre, and then a old diesel car and a new battery electric vehicle to do direct point-to-point. Next slide, please. And this, not going to go into detail, but this gives you a visual on the different routes. So you can see there's quite a wide range of routes, distances, but ultimately all going from one point in London to Oxford city centre. Next slide, please. So the kit we're using, so to measure the ultrafine particles, we're using a system from NAQTS, a UK company, which has a particle counter down to 15 nanometers and also measures the CO2, all of this at 1 Hertz. Next slide, please. And for the VOCs, we've used a state-of-the-art 2-dimensional gas chromatography equipment with time-of-flight mass spectrometry, capturing the sample on thermal desorption tubes as we go. And we did both active and passive sampling, so pumped sampling and passive sampling onto the tubes, and we found that the active sampling was the more effective. On the right-hand side is actually one of the 2-dimensional chromatograms from the testing. Next slide, please. And again, so we look at the VOC results first up. So here we've got a table, and obviously there's a lot more detail in the full report, but headline. So this is showing you between the various different journeys or journey segments, what the total VOCs were in mass, using a toluene equivalent standard, summed up by the different high-level functional groups of those VOCs. So you've got alcohols, you've got alkanes, alkenes, and that broad group. And then the more concerning ones, the aromatics, which tend to lean more towards being carcinogenic, and particularly the polycyclic aromatic hydrocarbons and the nitrogen-containing ones, which tend to be, at certain concentrations, the most toxic of the lot. We've also added in, because it's quite important, the breathing rate. So how much air are you taking in? And this is particularly relevant to the going on foot, on bicycle, because the concentrations may be quite low, but if you're breathing in a lot more, that in terms of your aggregate exposure could be higher. So we can cut and dice the data in lots of ways, but this essentially gives the building blocks then for emissions factors. The things to pull out, obviously there's a color scheme there. Really the mode which stands out of all of these was the most problematic was the coach, where it had, particularly high on the aromatics, quite high on the PAHs. The other one which came high on the PAH side was the diesel train from Paddington directly to Oxford. I'm not going to dwell, go into a lot of details. We don't have time, but we can in the Q&A can deal with some of that. I think the reason for the coach being particularly problematic is it was a heady cocktail of VOCs originating from inside the coach in a relatively small volume of air per person, and also quite a poor ventilation system, meaning there was also a lot of ingress from pollution from externally on the road, topped off by a very long journey time. So that's why I think overall, if there was one mode coming out from this piece of work, which was the most work to do to improve, it would be the coach. Next slide, please. We can also drill into a little bit more detail, and get an idea of what types of sources were generating these VOCs, and to give you a flavor of the ability to identify individual compounds. So the top chart, basically we've categorized where we think is the most likely source for each compound. And actually across them, essentially the one that dominates is personal care products. Now these are likely to be the least toxic. So just because they're the most prevalent doesn't mean they're killing you instantly, but they are nevertheless having some low level effects potentially, as well as discomfort. The second most prominent and the most concerning is possibly the fuels and lubricants. Now that is probably largely from other vehicles getting in, but some of it in terms of the older public transport may also be from the vehicle itself getting into the structure and into the cabin. What's interesting, less prominent than I perhaps thought, was actually plastics, clothes and surfaces and the like as a source as well. And then the bottom chart gives you an idea of just picking out some of the most prevalent compounds. And the top one is from personal care, but doesn't really have a health risk. Nonadecane would be from a diesel engine getting into the vehicles. And the other three are all from personal care products, which really are irritants at worst, and also fish don't like them. But how much of that is actually going to get into the sea is probably quite limited. So, but that gives you, that's just the surface of it, because gives you a flavour of what we've been able to see. Next slide, please. And again, please. And so here's the particle exposure. Again, you can see the highest coarse particles are on the underground, essentially skin, fluff, and metal. From not very pleasant to think of, but it's there. Ultrafines were highest on the electric train, and it's always important to interpret the particle number, particle mass in the context of the CO2, which gives you an idea of the air exchange rate. Next slide, please. So my last chart is just looking into a little bit more detail to give you a flavour of how we can sort of diagnose what's going on. So this is one of the journeys, the electric and then diesel train via Basingstoke. And you've got here, the purple line is the particle number concentration over time, and the green is the particle mass, so the coarser particles. And so you can see here, the London Underground gives you the coarser exposures. Then the electric train actually has got the high ultrafine particles, particularly spiking around interchanges and stations. And actually the diesel train, interestingly, has lower particle number and mass concentration, probably due to quite good filtration, but you still see the characteristic spikes at each train stop on its journey. So it gives you a nice visual of of the level of detail we've been able to pick up. Next slide, please. So in summary, and I should say, I haven't had time to talk about active travel, but if you were able to cycle or walk from Paddington to Oxford, that undoubtedly would be the lowest exposing. Take you a hell of a long time, but it would be definitely the best from a toxic exposure point of view. If you have to go by other means, trains was a very mixed performance. The coach was definitely the weakest. If you have to go by some non-active travel, essentially car is the best at the moment. And I haven't dwelt on it. The old diesel car was actually really quite good, probably because it was old, but it was a Mercedes with quite a good ventilation system. The new battery electric vehicle was actually not as good as that 12-year-old Mercedes. But the thing to note overall is very much exposures are dominated by large transient spikes. So that's why at stations where you get concentrations and maybe there's a cafe burning a sandwich or something, those sort of events are where you get a lot of your aggregate exposure from, and VOCs come a lot, sadly, from your fellow passengers combined with fumes getting in. So if there's one sort of policy message for public transport coming out, it is to have very good air exchange rate, but at the same time, very good filtration of the incoming air. And that's probably the quickest and easiest mitigation. So I know I'm about 1 minute over, James, but hopefully that has given you a whistle-stop tour. So thank you very much. And there's my key findings and impacts, and happy to discuss. Thank you very much.
Thank you very much indeed, Nick. Fantastic presentation, but really ambitious project that you've carried out. We've provided relatively modest funding, and it's absolutely fantastic to see these findings, which I think are going to prompt a great deal of further research. I invite people to put their questions in the chat and I can relay them to Nick. Those of you who've selected the breakout group corresponding to this project will have a chance to perhaps talk in more depth with Nick a little later. Meanwhile, just one question for you, Nick, on the sort of technical point from Transport Initiatives. The content of your talk has been extremely interesting. It's going to provoke questions, I think. And the question is, I note the confidential statement. Does that mean we can't talk about the findings at all yet, or just that we can't reproduce the slides?
Fair question. In a sense, you funded this, so this is now yours. So I put that on just to be cautious. So it's actually, in a sense, no longer mine. So if you're happy for it to be distributed, I'm very happy for these slides to go. And in fact, I mean, the point of this is to disseminate the knowledge. So actually, I would be personally delighted to circulate it and for people to quote it, use it as they would like.
Thank you, Nick. Appreciate that. So we will be making the recording of this summit publicly available. We will also be making publicly available the reports that the project leads have kindly put together on their projects that will include links to publicly and freely accessible data from the projects. So I hope that answers that question. I'll just have a look at the chat again here. So there's a question here from Vanessa Liberson. Were there windows that could be opened on the coach? If not, would the presence of open windows make it better or worse? Nick, can you speak to that?
Yes, I bet it was one of the more modern ones, one of the newer ones, and I think they were all sealed windows from memory. So I don't think there was any opportunity for that sort of manual ventilation. It would have made, I mean, it's a bit of a sweeping statement, but I would have expected in that case, it would have made things a lot better, yes. And to draw an analogy, you know, when we're testing the interior air quality on we do it on a lot of cars as part of our work. What we often find is that the pollution in the car with the windows closed can significantly exceed the average pollution outside. So what that means is, in practice, you would be, even if you're driving along a road which has occasional, you know, plumes of pollution, on average, you might be better to have the windows open than keep them shut and be essentially stuck with a poor ventilation system. So yeah, as we found with COVID, there's a lot, opening the window can do us a lot of good.
Thanks, Nick. Quite a lot of questions coming in. I'll try to put 2 or 3 further questions to you before we move on. From Francis Pope, who presented a moment earlier. I presume a lot of the volatile organic compounds will come from degassing from furniture. So older vehicles better from this point of view, i.e. already degassed?
To some extent, the total amount that we could ascribe to interior furnishings was actually somewhat less. I mean, very much there, but somewhat less than we expected, and it was more dominated by these person-centric and then inbound pollution. And part of that, we didn't find quite as strong sources from the new Vauxhall Corsa battery electric vehicle than we perhaps expected. They were definitely there. And in other work, we have certainly found noxious compounds in car carpets and things like that. So what it tends to be is very vehicle specific. So you can have a brand new car, which is actually okay, or a slightly older one that isn't. So it's a little hard to generalize, but I would say actually above that, fumes coming in and smells from other passengers dominate the off-gassing from the materials.
Okay, thank you, Nick. Actually, Sayed asked why the exposure in the electric car appears to be worse than in the diesel car. Any thoughts on that?
Yeah, we think, and putting it into the context of other testing we've done to give us an idea, essentially because it's a cheap car, I think. So with relatively rudimentary filtration systems. The key with it's all about balancing the filtration versus the CO2 buildup and the energy required to circulate the air. And one of the reasons for choosing the battery electric vehicle was range is at a premium with these cars. And so they often skimp on the energy put into the ventilation. So that, whereas the Mercedes was a big old diesel engine, you know, the ventilation system is a tiny fraction of the energy used there. So essentially, we find this a lot in the new BEVs and hybrids, is skimping on ventilation to save range.
Thank you, Nick. Okay, I'm sorry, I'm going to relay just 2 more questions and ask fairly brief responses from you, Nick. From Kayla Schulte, excellent tangible findings, very curious what Dr. Bartington's, Zoe Susanna's lead of the network, what her health specific interpretation of the results are. And how can we put Nick's ventilation related recommendations into practice? Which government agencies, organisations need galvanising? Perhaps, Nick, you can just very briefly touch on government agencies, organisations that we should be approaching with the findings of your work.
Yeah, well, I think the key to it actually is there isn't a standard method at the moment for measuring these things. So governments are not really rather unable to do much until, I mean, obviously they can influence the publicly owned fleet, but really you want something of more general applicability. I'm actually chairman of SEN Workshop 103, which is trying to standardize the measurement of vehicle interior air quality. And so I think that starting with cars, but so if I had one wish, it would be that that work is expanded to apply to public transport, so we can then start gathering good data on that pollution, and then policymakers will find it easier to make sensible interventions.
Thanks, Nick. And finally, and if you will, just in 20 seconds, hi, Nick, you said that active travel saw lowest exposures despite traffic. Is that with or without considering the breathing volume mentioned by you earlier?
Good question. So on the table, it doesn't correct for the breathing volume, but even if you correct for the breathing volume, you're still better. Obviously, it's not, the margin is less so. And we put it down to the fact that, yeah, you might cycle through a plume from a bus, but you're ingesting an awful lot of clean air in the meantime. So there is a significant dilution factor going on. Was that 20 seconds?
That's fantastic. You've done a fantastic job presenting, answering questions bang on time. So with that, thank you, Nick. I'm going to move,
thank you very much.
Going to move to Dr. Fiona Crawford, Research Fellow in Transport Studies at the University of the West of England, to talk about characterising changing travel patterns in the COVID-19 era. Over to you, Fiona.
Thank you very much, James. And as they say, now to something completely different. So I'm going to be talking about travel behaviour today. So I'm sure all of us have completely changed the types of trips we're making over the last couple of years, particularly with a large increase in working from home. Next slide, please. But what we've found is even though lots of the behaviour in terms of commuting has changed and people still working from home, we found that by now traffic flows are pretty much reaching a similar volume as they were pre-pandemic. And in terms of air quality, there's been very kind of mixed results in more recent times. So during the first lockdown, the first national lockdown in the spring of 2020, things there were relatively consistent, but since then there's been quite a lot of different information depending on which cities you're looking at in terms of the impact. So what I wanted to do with this project is to look at what's happened really with travel behaviour during the pandemic, and rather than looking at a whole citywide level, I wanted to really drill down into a few different aspects of that. In terms of whether that varied by space and how individual people's travel behaviour are changed. And by travel behaviour, for this research, I was only looking at road travel. So I was looking at vehicles on the road. So the data I used was from number plate cameras, and I was just looking at the city of Bristol. But I combined the number plate data with data from the DVLA, so that I could actually look at the characteristics of those vehicles, so the type of vehicle and certain information about their emissions. Next slide, please. So I was originally given data from over 100 cameras around Bristol City Council area. I did a lot of cleaning. I wanted to make sure that I had consistent cameras over the whole time period I was looking at. So that time period was from a year prior to the pandemic, so basically from March 2019 up until the end of September 2021, and ended up using data from 64 cameras, so 29 locations around the city. And I can't give specific details of the locations on the map because the cameras are shared with the police. So apologies that they are quite big squares. But Bristol is right in the centre there. The city centre is right by where the F and G blocks are. And you can see that the major routes into the city centre are covered by these cameras. So it should be borne in mind when you're thinking about the results that these are very specific types of roads in a specific type of area. Next slide, please. So I ended up with an awful lot of data, as you can see, did some cleaning and ended up with about 364 million observations. So then I did processing to turn that into trips. So if a vehicle passes one camera, it's observed once, but as it carries on its little trip, maybe into the city centre, it might pass another 2 cameras. So I wanted to have those connected together into a trip. And once I'd done that, I used the DVLA API to look up the information about the vehicles that made those trips. There's a total of about 3 million vehicles over that whole period. Next slide, please. And then there are 3 different types of analysis that I really did with the data. First of all, looking at an aggregate level, then looking to see if there were spatial differences across Bristol, and then thirdly, looking at individual traveller behaviour. Next slide, please. So the initial aggregate level data, you can see just the volumes of trips on the left-hand side there. This was almost just a sense check, really. So I was able to check this against traffic flow data from traffic counters, so a completely different source of data, just to check that I was getting the same patterns, which indeed I did. But using the value of using the number plate data is I was able to look at things such as in the right-hand side here, which is looking at the impact of the pandemic and which types of travellers, which types of vehicles it was affecting. So that massive drop that we saw at the end of March 2020, was that because infrequent visitors to Bristol were no longer travelling at all? Or was it equally affecting the very frequent trip makers in the area, as well as the less frequent trip makers? So that's the kind of thing we can look at with the number plate data. Next slide, please. So looking at the data from the DVLA, as we'd probably expect, the vast majority, so over 80% of the trips were made by cars, and the second biggest group was vans at about 14% over the whole time period. Although if you look at the graph at the bottom, this has the split between the percentage of trips made by cars and by light goods vehicles, or by vans. And you'll notice that during April 2020, and then again in early 2021, when we had national lockdowns, we had an increase in the percentage of vans, a slight decrease in cars. So it increased from about 12% of trips made by vans up to about 19% of trips. So almost 1 in 5 trips were made by vans during the, thank you, James, during the national lockdowns. What perhaps surprised me a little bit is towards the end of the graph, where things have pretty much gone back to pre-pandemic level. So whilst there's been a lot of discussion, about people now shifting to doing all their grocery shopping online, this kind of suggests that maybe there was a more limited time span of that change, and now behaviour is shifting again. Next slide, please. So then looking at the spatial differences. So here I wasn't looking at individual locations, I was looking at individual kind of routes, so origin destinations of trips through the network, and seeing whether there were any differences in how the pandemic had affected those different kind of routes through the network, to get a bit of an idea of spatial differences. What we found was that the majority were in group 1 on the left-hand side, where after the lockdowns, there's been a certain amount of bounce back in terms of the number of trips, but it's still not reached the kind of level it was pre-pandemic. Whereas in group 2, you can see that there was a much more of a bounce back in terms of trip volumes, and even ended up exceeding pre-pandemic levels. And discussing this with Bristol City Council, who provided the data for the project, when we looked at the specific locations that fell into group 2, they were saying that they're very much trips that wouldn't be associated with commuting so much. So we've got kind of other trip purposes there, which are showing quite different behaviour in terms of the number of trips. And also one of the sites is very close to a park and ride location, and they have experienced a massive impact due to the pandemic. So people now may be driving into the centre of Bristol rather than stopping at the park and ride. Next slide, please. And then looking at the behaviour of individual trip makers. If we just go to the next slide, so there we go. So there's more detail about this in the report, but I just really wanted to flag the slightly crazy graph on the right-hand side there. So this is looking at the same group of regular travellers or regularly observed vehicles in Bristol. On the left-hand side is how frequently they were travelling in 2019, and on the right-hand side in 2021, and the lines between them are individual travellers. And my basic message about this is it's a bit of a mess. So I think so much of the discussion about the behavioural response has been, oh, people were working from home, you know, during the earlier stages of the pandemic, and now people are going back to working in offices, and that's why trip numbers have increased. And we're seeing a very different pattern when we look at the actual data. So for some people, we found for the people who were making trips in 2019 and 2021 in the spring period, about half of them were making roughly similar numbers of trips between the 2 years. A quarter of people were travelling less often, and the other quarter were travelling more often. So you just got so many different factors at play based on things like job type, people's experiences, people's preferences, perhaps the use of other modes, so people not wanting to use buses so more. But I think for me, probably not the ideal outcome of the research, but that we need a lot more research to really understand what people are doing. Because next slide, because the implications of this is that there's so much is changing. People are traveling to different places for different purposes at different times of the day, and the policies that we've developed, things like related to clean air zones, for example, the whole kind of basis for our decision making has changed, and we need to really consider whether we need the same policies, and we need to reconsider what impact the policies will have. Because, for example, a lot of people who can work from home are now working from home. So those would have been a lot of maybe quick wins in terms of charging clean air zones. So hopefully this has given you a bit of an insight into how things are changing in Bristol, and hopefully similar to what we're seeing in a lot of other cities too.
Thank you very much indeed, Fee. Very interesting findings, and impressive to tease out, even to some extent, patterns from so much data. We've got very interesting comments and in places conversations in the chat, so I refer you to look at the chat and contribute to it if you've got questions now on Fiona's work. We will also refer to the chat after this event as we look to next steps. I'll ask a colleague now, Katie, if you could save the chat at regular intervals, that'd be super. But time for just a couple of questions. Firstly, from John Fairburn, what percentage of working population is now working from home, and how frequently? I'm struggling to see how traffic levels can be back at pre-pandemic levels. You may not have numbers at your fingertips, Fee, but can you speak to those questions?
I did know the number at some point. I've done some research looking at various different data sources, and the ONS have some quite good data on this. I think the key thing for me really is that the overall percentage of people working from home isn't very helpful, because it depends so much on the industry. So, for example, in Bristol, a lot of the people working in the city centre, they're more likely to be able to work from home. The types of jobs they have, the kind of tech workers whereas we have in the north fringe of Bristol, and we have a lot of factories and things like that which stayed open. So we've got a lot fewer people working from home. But it's such a rapidly changing position. I was speaking to Bristol City Council this morning, and they were saying that they've seen a massive jump in the last 2 weeks in terms of congestion, and in terms of kind of just speaking to people. You know, a lot of organisations have now said, right, we want you to be working from home half the time. So I think it's quite difficult to get a good measure of how many people are working from home, because yeah, it's kind of constantly changing. But I think it kind of highlights the problem we've had in transport for the last, I was going to say 50 years, maybe 70 years, is that we really focus on commuting, when an awful lot of the trips on the network are not commuting trips. So, for example, travel to school, that now is going to be similar to what it was prior to the pandemic. People may still be driving children to school, even if they're now not driving on to work afterwards. They might be traveling home to work from home. So that will still be generating trips. And we also find that people working from home tend to make more other trips during the day. So they might go shopping, or pop out for a coffee or that kind of thing, or pop out for lunch. So we've got, I think the idea of the trip purpose is really important, which I couldn't get to the bottom of in this data. But yeah, as you say, it's working from home is a big contributor, but understanding why those traffic volumes have gone back up is really important. Sorry, James, that's a very long answer.
No, I think you've elaborated very well there on differentiating between some of the temporary impacts of COVID and what may or may not be legacy effects. Very, very interesting. Very quickly, one technical question for you around when did the Bristol Clean Air Zone begin? Did that affect, is that included in the period that you've studied?
No, it hasn't begun yet. So yeah, so it doesn't matter for the data that I've got, although Bristol City Council were really interested in the fleet composition estimates that I made, because they were expecting people to already be changing the type of vehicle they have, ready for the Clean Air Zone, but that didn't seem to be the case. But yeah, it's not a problem for this data.
Thank you, Fee.
Thank you.
And with that, we will move to Gordon Allison, who is Principal Consultant at DustScan, to talk about their project progressing real-time source identification. Over to you, Gordon.
Thanks very much, James. Despite the snowy background, I'm presenting this from Las Canteras Beach in Gran Canaria, off the coast of the Sahara in the Atlantic. And I had a discussion with Dimitris, who I worked with on this presentation before, just about the data. Then thought I'd go for a quick swim in the sea, just to calm my nerves down before coming back to present to you all. And the big waves, it's a big surf beach. And I went in with my specs on, and big wave came over my head and washed my specs away, and I'm terribly short-sighted. So I was rather dejectedly walking back to the beach, wondering how I was going to manage this presentation the rest of my trip, when I trod on my specs, and the wave obviously took the object back to where it was heading, and I was heading in the same direction, and I saw it. Well, stood on them, and here they are. So this leads me on to this, what we're doing in this real-time source apportionment study, which is to do with transport, slightly peripherally, because you've got to build infrastructure, you've got to build roads and railways, and you cause pollution during those events. And at DustScan, we measure typically the larger particle sizes associated with infrastructure projects. We're interested in where particles have come from and where they end up. So we teamed up with Birmingham University because of their research on particle source apportionment to look at this in more detail. And the really important thing with pollution measurements in commerce and commercial applications and policy is being up to date. You want to know where the pollution is coming from now, where it's going, so you can make a decision to intervene and alter that. Researching it, reporting 2 years later, you know what's happened. That's maybe fine for the design of a car or a bus or travel hub, but for active management, real-time knowledge or up-to-date knowledge is very important. So if you can move on to the next slide, James, I'll just describe a bit more. We all know the impacts of air pollution, and monitoring air pollution tended to be a niche activity with very expensive equipment, but the number of relatively low-cost sensors has expanded massively and made it available to other sorts of organizations and made spatial coverage much better. So that allows us to look in more detail at where pollution's coming from and going to. Got us going on this project with some sites, which I'll show you in the next slide, please. This work was started by Birmingham University to look at the size distributions of the particles from laser particle counters, so optical particle counters, which measure in the sort of high nanometer to microgram size. And by looking at the particle number size distributions and analyzing it with where they've come from, you can tell whether particles have come from road traffic, for example, or the sea, like that big wave that knocked my specs off earlier, which I managed to get into James's presentation very quickly. That's only a joke. So if you move on to the next slide, this shows us the aerial photo of Birmingham Curzon Street construction site, where we've got a monitor on the northern boundary of the construction works, and the brown bits are the soil where the site has been cleared, and you can see the main line, West Coast main line, going into New Street, just on the bottom half of the picture. You, move on to the next slide, please, James. In measurements we took October 20 and analysed, we could see with this relatively low-cost machine over the time period here in about a month that there were very definite size patterns in the particle number size distributions. And factors 2 or 3, which are effectively mathematical factors, show that they're characteristic of activities on the construction site. So we could look at the pattern of the particles and deduce something about where they came from. So if you look in the lower graph of factor 2 with a high diurnal variation, it shows that that's a background, that it's a constant source. And if you look at the lower 2, factor 3 and 4, you can see that construction activities on the site on High Speed 2 that month stopped at the end of September the 21st. Next slide, please. These open air plots taken from the same time, you can see, if you look at the bottom left-hand corner, you can see factor 3, where during the middle part of the day, the redder colouring shows that you've got particles coming from the southwest when the wind blew, and from the northeast. And factor 4 shows that during the course of the day of activities on site, in that time period in the day, we're generating particles from all directions. So that gave us good confidence that our method was working. Next slide, please. This next set of measurements were taken from Tarmac Mount Sorrel Quarry, where they quarry and mill up the aggregate for the roads, for the tarmac surfacing. And the monitor in this was roughly in the centre of the picture, with the quarry to the southwest and south. And again, we got factor patterns that were characteristic of the size of the particles. And these are larger particles than Nick Molden was measuring from the interior of vehicles. These are tend to be in the 2 to 3 micron size range. Next slide, please. And again, you can see in the factors below that you could see activity-related contributions, and in the open air plots above that there were contributions in factor 2 and 3 from the southwest. So again, activities were showing that they were contributing particles to what we could measure. And if you move on to the next slide, please. So what we found was that there were only strong wind periods which contributed to air pollution significantly from the quarry. And although they breached the WHO guidelines, they're in air quality limits. But what we would find with clever analysis of relatively low cost particle counting data is that we could tell in more detail what was going on in the locality of these pollution sources. Okay, next slide, please. So automation is key to this. So we're continuing to collect data sets and interesting sources, not just typical dust generating sources, but sources that are of interest and are of interest in air pollution control and policy management. So as we grow our data set, then we'll be able to work towards looking at them in real time to be able to tell managers and regulators of pollution sources what the issues are. Next slide, please. So this is an image of our dust scan cloud monitor that's on Curzon Street size boundary, and we're carrying on collecting data sets and working towards developing the automation process. And we'll be interested to hear from people who are managing or interested in particular sources of particulate pollution. And that's it.
Thank you very much, Gord. Excellent presentation. And as I invite people to put questions in the chat that I can relay to you, I just wonder, at the moment we have a sort of explosion of development of low-cost sensors. And I think we all know that they're of variable quality, and some are much more reliable than others. Also, the measurement techniques are more straightforward for some chemical species of concern to us with regards to air quality and human health than others. And with particles, you've got a better shot at making good measurements, particle number, with relatively low cost instruments. I was just wondering whether, given your technique is focusing on the particle size distribution, the sort of shapes of those distributions, whether you're also sort of insulated somewhat against, accuracy with respect to producing, measuring absolute concentrations.
That's a difficult question to answer easily, but yes, I think you perhaps are, but this instrument of ours, it mainly returns mass concentration. You aggregate up the particle size bins, assume a density, and report micrograms per cubic meter of PM10 and PM2.5. But But I think, if you've got both, the more information you've got, the more you can find out about your pollution situation. And what we're doing is effectively using the rich data that's associated with this method. And we have deliberately focused on particles for their reliability of the method of laser optical particle counting being, very tried and tested method. But we're interested in adding gases and looking at other pollutant gases at the same time. But it's sort of taking data in chunks that we can assimilate and do the analysis on and make progress, rather than trying to acquire too much data that we just can't find our way through, if you like.
Thank you, Gordon. Very, very exciting to create this opportunity to gain valuable information on source apportionment from measurements with relatively low cost sensors, giving potential high spatial coverage. Very, very interesting. Any questions, please pop them in the chat. We've got just a short time before we should be progressing to the next speaker, so just give you a moment. And a reminder that we will shortly be moving to breakout group discussions, where you'll have a chance to converse with project leads in much more depth. If we have no further questions, I'm going to move on now. Thank you very much again, Gordon. Really appreciate that. And introduce you to Dr. Fabrizio Bonatesta, Reader in Thermodynamics at Oxford Brookes University, to talk about their project focusing on minimising public exposure at the roadside. Over to you, Fabrizio.
Thank you very much, James. First of all, thank you very much for using a picture of me from 12 years ago. Thank you. With all the hair there, with the right color, so fantastic. Sajjad and I, in the next 10 minutes, maybe 11, we are going to talk about our mini project funded by the Transition Network. Thank you very much for this. We've been doing 3D computational fluid dynamics modeling of pollutant dispersion in the roadside or to the roadside, and therefore people exposures, especially with a special focus around and inside the bus stop shelters. Next slide, please. So with this video, I wanted to sort of very quickly summarize what we have been doing in the last few years at Oxford Brookes. We developed this high resolution CFD model of pollutant dispersion from moving traffic. And by borrowing or stealing a sentence from Nick from the first presentation, exposure is dominated by spikes of pollutant emissions. That's the case for in-vehicle air quality. It is the case on the roadside and in many other circumstances, transport hubs, anywhere you are in an urban polluted context. So pollution migrates, as you can see from the video, from the tailpipe of the cars or from non-exhaust sources into the roadside, depending on the wind, and people are exposed, as continuously exposed to momentary but very high peaks of pollution. In this case, NO pollutions, but any other pollutions such as particulate matter. Within this project, we wanted to develop our software model further. We wanted to give some validation. We know the software, the model returns realistic results, but we wanted to go further with the validation. And also, as I said, assess the situation, the exposure situation in and around bus stop shelters. This is my very easy part, and then Sajjad will continue with the technical results. Thank you very much. Sajjad, over to you.
Thank you. So if I just dive into it with constriction of time, if you could go to the next slide, please, James. So in order to develop our CFD model, we have to do a bit of an experimental campaign. With the help of Oxford City and Oxford County Council, we have identified 2 roads in Oxford City Centre to be able to carry out our measurements. Measurements have been done using Combustion's fast response NOx systems. What we have done was we chose these 2 roads because they were almost not busy traffic really roads. We have identified those 2 roads to give us a semi kind of controlled environment, but realistic. To be able to produce controlled pollution, we have mounted a bottle of NO, 10,000 ppm NO on the back of an electric van to run for about like 110 meters across the road. And we had the measurement system on the side pavements. So the rubber pipe, as you can see, coming out of the back of the van was dragging NO from the bottle mounted in the van. So in total, in 2 roads, we have been able to do 69 test repetitions to be able to produce enough information for our model. If you could go to the next slide, please. So having done the experiments, we had to get a realistic map and 3D layout of the streets and buildings to our CFD model. We used the LiDAR provided by the council for us, converted it to GIS open source software that gave us a 2D layout with a average height of the building. Having that, we took it to the CAD system, CAD software, and then into the CFD software. In the CFD software, we have been able to optimize our mesh and computational resources we could possibly afford for this project, using 2 meshing techniques, overset meshing and adaptive mesh refinement, which I'm not going to bore you with technicalities. I can answer a question about those in the Q&A. But in general, that gave us a total runtime of 12 hours for 12 seconds of running the simulation over 48 computing cores. Next slide, please. So due to the limitation of time, we have been only able to do the validation concentrated on Mansfield Road, which was almost a semi-open road. The other one was almost a street canyon. We have got good results, a good validation between the experimental and the CFD provided measurements. Although we have found that this validation could only be more successful against low variation and almost steady wind direction and wind speed. So maybe for future, when we have more complex flow, we need more an array of sensors distributed locally and also at the boundary conditions of the area. Next slide, please. So having done that, this was time to actually go to the aim of this study, which was evaluation of the exposure at bus shelters. We have been provided with 3 different designs from Clear Channel, which works with Oxford County and City Council. I'm sure they work with some other councils across the UK. There was a 2-bay insignia design on the right-hand side, the top. There was a 3-bay MK1, which has an advertisement on the panel on one side, and another one which is similar to the 3-bay Mark I, but has an open access on the rear side. We wanted to see how that open access really either help or, I don't know, how does it compare with the one with no access on the back. The problem variables were wind speed and wind direction. As you can see, they were coming at the cars and the bus shelters. So we wanted to see how the combination of wind direction and speed, how does it really evaluate against the exposure in the bus shelters. If you could go to the next slide, please. Having done the simulations across all the 3 cases at different wind speed and wind directions, I'm only presenting here for brevity only one case, but result has been almost consistent across the 3 designs. We are getting good protection in bus shelter when you're standing inside the bus shelter across against the NO values being emitted from the cars. By the way, those NO values are adopted from a study for Euro 5 diesel cars. So, but when we go to higher wind speed, which is called as a gentle breeze, but 5 meters per second wind speed, which is almost the average value in the UK, the protection drops significantly. The best we could get was 15% for Mark I, and the lowest was 5% for the 2-panel insignia. And the worst case generally was under 30 degrees of wind direction and 5 meters per second. We could get to the 6-second average of NO concentration, about 800 microgram per cubic meter. I'm saying 6 seconds. This 6 seconds is basically the rise of the exposure as it approaches the bus shelter. That's why we took that 6-second average in that 12-second simulation. And regarding that rear access, we wanted to look at. We have seen that although the average value of NO was almost similar for the one with Mark I and Mark IA, but the maximum values, because of the complex flow happening around that rear access, actually is higher. That might give us a better ventilation, but at the same time, it gives a higher level of exposure momentarily. If you can go to the next one. Having done that, we also wanted to see if we can do any kind of optimization, see if we do a bit of a tweak to the bus shelters, how would that change the exposure? So we simply looked at the literature. There were strong evidence that orientation of the bus shelters, either facing away or facing away, facing towards or facing away from the streets, can help. So one of our tweaks were just to rotate the Mark I bus shelter design facing away from the street, and the other one was we had a speculative design. We called it the MK1 OBU. We basically only covered the whole around the bus shelter, left a bit of vents at the top and bottom for people to be able to breathe, and a bit of only one panel access for people to come in, but facing away from the street. Having done that, so we have seen that we get a bit of a better exposure, reduce a level of exposure inside and outside the bus if people are bus shelter, if people are basically standing outside because there's always not enough space for people to be inside, or they just want to stay outside for better breathe. I don't know, they may just not feel comfortable feeling inside, but either way, it gives us a better level of protection. And with the MK1 OBU, we have seen that we consistently get a good value of about 35% of protection, improved protection compared to Mark I. If you go to the next slide, please. This is a bit of animation of what we saw for Mark I. So as you can see, as the cars approach the bus shelter, you can see the time resolved NO concentration increases and then drops as the car passes by. We have more of these animations, but just didn't have enough slides to put more. And if you go to the next slide. So in conclusion, since we have been doing this project, and before that we were doing it internally, we have found out both a steady and a queuing, meaning a start-stop traffic produces a large peaks of air pollution, which are people continuously exposed to. And we have found that hopefully we're validating this campaign with the validation campaign in this project. We have found that this model can be used for assessment of personal exposure, either in and around the bus shelters or traffic lights, any other scenarios, which hopefully we can further on use. Direct validation we have done, although we have figured out that maybe a bit of more complex array of distribution of sensors may be needed for more complex flows in the neighborhood of a street. And we found that in gentle breeze, we finally we may be exposed to a high level of concentration, although the bus shelters may do a good protection on their low wind speeds. Shelters facing towards offer good protection under, as I said, under low wind speeds, but facing away would be a better option for semi-open field roads, or we could do a bit of tweaks and optimization to make better bus shelters using this software or any other software that can do basically gas dissipation. This can be also used for PMs. Definitely, we're working on that too, to make, at the moment with the PM, it takes too long of a computational power and computational time. We are trying to make the software, the model even leaner to be able to run that within a constrained, limited and justifiable time. What hasn't been presented in this presentation was that we also did, we wanted to see how many, adding cars basically, how would it affect the traffic if it was aggregated like a proper flow of traffic, how would it really affect the exposure? We have seen that making the 4 cars to 8 vehicle configuration really generates an increase of average and all levels between 50 to 120%, depending really on the wind direction. Thank you very much. I'm happy to answer questions.
Thank you. Thank you very much, Syed. And thank you, Fabrizio. Absolutely fantastic project. Going to move within a minute to a 5-minute break. Very quickly, take one question from the chat. David Williams, some people may not feel safe in a bus shelter where there is no exit. This is one type of design issue raised by Caroline Perez in her book, Invisible Women. Any thoughts on this? I mean, I guess the size of the shelter can be transparent. That might help. Any thoughts on this, Syed?
Yeah, definitely. We have done a plexiglass protection around the traffic lights, and we have seen that works too. So if it was transparent, that would possibly be one solution to help with that for people to feel more secure.
James, we're trying to establish what different designs can do. We certainly understand that people might feel sort of claustrophobic inside a confined space, but this is very much open to debate. Let's understand first how we can protect, and then we adapt it to something that is feasible and acceptable for people, I guess.
I think you've done tremendous work there, developing a tool for further research, but also applying it to a real world situation to help reduce exposure. So with that, I just want to say, we're going to give you just 3 or 4 minutes comfort break. When we return, you'll find yourself, I hope, in your preferred breakout group for discussion. The chairs in these discussions will then be feeding back from your discussions the top 2 messages identified coming out of each of these projects and top 2 priority next steps to advance research and policy in this area. If any of you find yourself not allocated to a group, please drop a message in the chat. We'll come back together, regroup at 3:35, 4 minutes time. Many thanks.
So welcome back, everyone. I think I can now see representatives of every breakout room back in the main group. So thank you to everyone on behalf of my group. We had a great discussion, and thank you to Katie for facilitating all the movements of us all. So my name is Felix Leach. I'm an engineer from the University of Oxford, and I'm going to be chairing this brief feedback session. So we've got about 2 or 3 minutes per group. So maybe I could invite Carl to start with some feedback from his group on Nick Malden's work on sort of 2 key messages and what 2 priority next steps were. Carl.
Okay, I think the priorities for us was in understanding fully and being able to communicate fully. So I've combined the 2 messages into one, I'm afraid, sorry. So firstly, understanding what these impacts are, what are the data, what are the pollutants we should be concerned about. And likewise, what are the things that are just stuff we marinate in, to use Nick's expressions. Then nextly, how we communicate that so that people are aware of it, so they don't get the wrong message at the end of that process. In terms of next steps, there's a very clear need to standardize the methods so that everyone is working from the same hymn sheet, if you like. And again, I think it will come back to that thing. Some of the things we can do might be very simple and very, very low cost. Like, for instance, improving ventilation, improving the filtration on vehicles, so we reduce the impact within the vehicle for people using them. And I think, again, Nick used the word comfort, and with the public service vehicles, we should be looking at them being an attractive option for people.
Yeah, thank you very much, Carl. I think that's a really useful sort of summary there. Charlotte, can I invite you to feedback on Fiona Crawford's work?
Yes, thank you. We had some really, really good discussions in our group. So key messages that we report back is the importance of context. Travel patterns have changed differently across different locations, and we need more data to fully understand those trends. And any existing tools now partially or wholly redundant, traffic modelling, fleet data, may now have changed substantively, sorry, I couldn't say that there, as a consequence of disruptive changes from COVID. So there was also then taking it forward, there was lots of discussions about, that there are surveys being undertaken and trying to link some of the data, not only obviously in Bristol, but there were other locations identified, and about looking for bringing together these data sets together to make more meaningful, to be able to understand and again communicate the results.
That's great. Thank you very much, Charlotte. Again, I think that's all really valuable. It's worth saying at this sort of midway point that please do leave your thoughts in the chat. We're capturing that as we go. And in terms of, sort of preserving this and acting on this, I think we're all keen as a network that we do this. And so, of course, this will be available online through the website. And I know that James and others are working on kind of distilling this down into real kind of action steps moving forward. So thank you, and please do add more things into the chat if you'd like to, because inevitably distilling a sort of 25-minute conversation down into a 2-minute summary is almost impossible. So with the impossible task next, Francis, could I invite you to comment on Gordon Allison's work and your group?
Sure, thank you, Felix. So I think the two main points that came out was that there's this real need for lower cost source identification or source apportionment. And so that's the first point. And then the second point was the technology that it's clearly demonstrated there's lots of areas where it can be used, as demonstrated already in the project outdoors. So Gordon talked about quarries and construction sites, but during our discussion, we talked about, great potential for indoor environments as well, and real possibilities along the Internet of Things route. And then going forwards, there was two main points I took away anyway. So the first one was to use more than one sensor, so a network of sensors. And we've talked about this in terms of measuring pollutant quantities, but actually we could start to think about triangulation of pollutant sources with the networks. So that was one direction of travel. And the second direction of travel was trying to bring in a measure of particle number concentration as well as particle mass concentration, because that would open you up to sources which are below the usual regulatory limits of PM10 and PM2.5.
Great, thank you very much, Francis. So if people have any questions for the groups, please do put them in the chat. We might have a minute or two to consider some of those if there's maybe something that you wanted to think about from a group that you couldn't attend. So please do pop those in the chat if you have them. And then from the group that I was in, looking at Fabrizio Bonatesta's work, using the CFD to minimise public exposure at the roadside. Again, a really great, valuable conversation I think we all had. For me, there were sort of two key themes to draw out from this. The first was that people at the roadside are exposed to very short duration, but very high exposure levels of NO in this case, but you could extrapolate that probably to pretty much all pollutants that you'd expect at the roadside. So what do we mean by short duration? Well, I think we sort of settled on about less than 5 seconds. And by very high levels, up to 2,500 micrograms per meter cubed of NO in this particular study. But, anything else that might be emitted from a vehicle, you could see similar levels of there. So I think that was a key message number one. And the second was that I can't quite remember who said it this way, but I think it really neatly summarized it. Design matters to exposure. So how we place our street furniture in some cases limits our exposure, but in some cases actually promotes it and increases it. So that kind of design and thinking about that more coherently was another key message from that. And so then the priority next steps, people were full of brilliant ideas. So picking only two has been really hard. But I think the number one we all agreed on was that we don't really know what the health effects of these very high peaks, but for very short durations are. So these exposures are very high levels, but for less than 5 seconds, there's very little data as far as the group could see on what that actually means for health. And so trying to devise studies in the public health space, investigating that, I think was a sort of a priority next step. And then the second one, I think, was looking at incorporating other data into this. So thinking about traffic levels, dwell time, maybe indeed drawing on some of the other presentations we've seen today could be really valuable in looking at different vehicle types and so on and so forth. So I think that was the summary of Group D and Fabrizio's work from Oxford Brookes. So I'll just give everyone a minute or so if they have any questions that they have on their minds about these groups. Do put them in the chat. But if nothing appears, then the risk of completely jinxing it, we appear to be running 5 minutes early. And it gives me great pleasure now to introduce Dr. Gary Fuller, who I should say needs no introduction, but I'll give him one anyway. So Gary's from Imperial College London. He's an author, an academic, very well known in both of those spaces. But importantly for us, he's also a UK clean air champion, and he's going to offer some reflections on today's summit. So Gary, over to you.
Thank you, Felix, and thank you to Suzanne. Thank you to everyone for inviting me along this afternoon. Really great discussion, really great projects. And I flitted between each of the breakout rooms, though I only managed to get between 3. And so there was some really good discussion there. I don't think I can possibly reflect on everything I've heard and all that you've done. But just a few thoughts. Suzanne introduced the whole SPF, the whole Strategic Priority Fund around air pollution. And I think when we often think of this in terms of the sort of more traditional research projects that are going on there, but I think the networks such as yours are just an extremely important part of the whole process. And you're capturing so much in terms of interdisciplinarity here and bringing together so many different communities. As the SPF is evolving and we're looking towards the second wave now, all the projects have been let, we need to start thinking about legacy, and we need to start thinking about moving forward, how these things will continue after the end of the SPF. And I really hope that the networks that are being created here will have some sort of longer term future, that those of you that are working together will continue to work together either under this umbrella or by bidding for future projects. So I think that's really great. In terms of transport and air pollution, I'm sure if you go and talk to the average person on the street or the person on the Clapham omnibus, I don't know, you're talk to them about air pollution, it's not long before they point to the nearest road and probably to the nearest bit of diesel traffic. And there's a real presumption amongst many people that the problems from air pollution from transport will be solved by electric cars or clean air zones. But really, I think when we begin to think about this, it would be a massive missed opportunity if that was our solution to air pollution from transport. I think it's often said that, well, I often say it anyway, that if we were to pursue active travel rather than just changing the drive chain of our vehicles, we can tackle air quality, we can tackle climate change, we can tackle the urban noise that plagues the lives of so many people, as well as we can do something about the massive health burden that's caused through just the inactivity in many of our daily lives. So the potential for the topics that you're doing is just enormous. There's a big public appetite for these as well, and I think it's bigger than we might recognise. I was part of a citizens' assembly that was done in my local city, and I was really nervous about the way that this would go. You know, you take 50 odd representative members of the public and you think, oh my word, we're going to listen to them, and what are they going to come up with? And what they actually came up with was really good. These were really good suggestions. They weren't necessarily the ones that I would have put forward, but they showed tremendous appetite for change and people wanting to embrace the whole topic of transport, air pollution and its environmental disbenefits. To use a phrase, I suppose, from Carlton Reid, or to perhaps slightly adjust one, the majority of our cities and towns were not made for cars. You know, our roads were not built for cars. The area I live in, the roads were laid out more than 100 years ago. And it's probably the case for many of the places that you're in. And the way in which these spaces are now used is just incredibly complicated. We've got concepts coming forward like 15-minute cities, for instance, as solutions to these things, which brings us really nicely to some of the work that Fee talked about earlier with the ANPR. And I think the messages that I took away from that was just the complexity of individual behaviour and how we shouldn't be taking many of the things that we've previously assumed for granted. So, for instance, it raises the question of if people are changing their focus perhaps to local trips within their community, it gives us many more options to solve the transport problems by creating local services, you know, the 15-minute city concept, but it also requires us to really reappraise our policies. And there's questions posed there, I think, you know, are we missing new localized hotspots of air pollution that aren't just the ones we traditionally had around the trunk roads? They're the ones around our congested urban areas with perhaps a great deal of exposure. I would like to say that I think it would be really nice if there can also be a focus on the movement of objects. We spend so much of our time talking about the movement of people around urban areas, and we spend very little time talking about the movement of objects. It's one of my favorite tricks whenever I'm in meetings with transport planners after they're presented for a while about the nearest tube station and bus routes and all of these things. I generally encourage them to look out the window where there be some HGVs going past and say, well, where are they going? Where have they come from? What are they doing? Why aren't those in your plans? And I think that's a really important challenge for everyone here as well. One of the other things that's coming out and building on Fee's work with the ANPR, which I think is really exciting in terms of technology changes, we're starting to get some really interesting views on footfall. So footfall's been collected for some time, you know, by your local shopping centre or your high street, and you know, for in sort of retail demand. But if we can begin to understand footfall and the way in which people are walking around our urban areas, then that does that in the same way as Fee's looking at ANPR data. Does that open up opportunities to be able to influence that, to be able to change that, to reduce not just so much concentrations by encouraging, you know, active travel and modal shift and so forth, but to be able to reduce exposure. And I think that brings me neatly to the work that Nick presented. You know, it's an evolution beyond what we normally talk about in air pollution from outside or exterior concentrations into one, exposure, and two, the whole idea of within mode or indoors. I sit on AQUEG, and at the moment it's no secret that we're preparing a report on indoor air pollution, and we're debating some of these things. And you've got to say, if we're regulating outdoor air pollution, should we not be applying the same to indoor public spaces as well? And one of the pushbacks that normally comes from this is that they're regulated in the same way as you regulate workplace and occupational exposures. But, you know, this and those limits are set to be far higher than they are for the ambient world. But if you look on your bus or your coach between Paddington and Oxford, you might find my very elderly parents there, or you might find children. And so, you know, we should not be thinking of these indoor enclosed public spaces in the same way as we are thinking about occupational spaces. We do need to think about the exposures that happen in them. And as Nick points out, they're really quite different. And for some pollutants, they might be quite high. Which ones are important that they're high for, I don't know. But I think it really opens up something that we do need to face up to, which is how should we be protecting the health of people that are using indoor public spaces? And I think I include transport modes within that. So there's stations and there's many others, as well as retail environments. You know, my parents go into Sainsbury's as well. You know, we push small children in buggies into Sainsbury's. Well, other supermarkets are available. So moving on from beyond that as well, a lot of the people that are exposed in indoor driving environments, of course, are workers. And so, you know, there is a responsibility by their employers as well to ensure that what they're exposed to is not harmful to their health. And I don't think we entirely understand that. And there's some really, really important questions there. Most of the evidence that we have, again, coming out from the work we've been looking for AQUEG on sort of air pollution concentrations and exposure in travel environments is incredibly outdated. And most of it comes from times when, I mean, Nick points out, you know, if you take your modern vehicle, you don't actually get that much out of the exhaust pipe these days. But most of our data that we have on exposure within transport environments is really very old. It's a couple of decades old, whereby the transport environment that vehicles were traveling through was very different to what they are now. You know, it's the air pollution in your car is influenced by the vehicle in front. That has changed. The vehicle in front is radically different now to what it was 20 odd years ago. So there's a real need to relook at those evidence again and to really reframe this as an important exposure time. And if you look at, you know, we do spend quite a lot of time in transport environments moving around, but they're very, as when I dipped into the breakout group that I was talking about, Nick's project, I mean, there was a point raised that it's very, very complicated when we begin to move indoors about the different pollutants and the different sources, which brings me neatly to Gordon's work. And I think there's, you know, great opportunity there if we can come up with ways of being able to use particle size that can be collected in fairly portable or low-cost ways to help us understand the different pollutant sources that are affecting environments. And there are some simple ways, as Gordon was putting forward, whereby you can split and understand sources by size, and having this as another sort of tool within our sort of identification matrix could be really, really useful. But also, before we move away entirely from this, or before I reach the end of what I was going to say in terms of exposure, I think Fabrizio's work around bus stop design was really interesting, and some people were throwing into the discussion about how comfortable people feel within, you know, enclosed bus stop environments or enclosed public spaces, and that's an interesting point to be built in here. But if I go and stand in my bus stop, for instance, it says that I can't smoke. Well, not that I am a smoker, but it's a place for which smoking rules, you know, indoor smoking rules apply, as are other arenas like, you know, my indoor retail, my shopping space, my public drive, my public transport space as well. So if we're already beginning to regulate those types of environment for tobacco smoking and ETS, is it really, you know, such an extension to be able to regulate them for our exposure to other pollutants? And lastly, on Fabrizio's work, Felix, I think you said something really significant just in your kind of summing up and passing this on. And I think probably that it's the lesson from all of this today. And you said design matters for exposure. And I think really that runs through all of these projects, and it's something that we do need to bear in mind. We do need to be putting a lot more design into our transport environments in the broadest possible sense than we're doing so at the moment. And part of that needs to be around not just moving people. It needs to be about moving objects, but it needs to be about the pollutant exposure of those people as they're being moved around, as the objects are being moved around. So I'll leave you with just that last thought, that design matters for exposure, because I think that's fantastic. So thank you all very much for inviting me along today, and to hear about your projects, and I look really excited to see the next steps that you're going to take going forward. Thank you.
Thank you, Gary. It's been a pleasure to have you here, and thank you for summarising the core themes that have emerged across the projects. I just wanted to add a couple of my own thoughts from the perspective of being network lead for transition. I mean, firstly, just to say what fantastic work on such a tight budget. And the value for money from these 48,000 investment from transition, I think is just evident. And a thank you to all the project leads as well for navigating university administrative systems, which are not always the easiest, particularly for these small pots of money, I know. So thank you for persevering there. But I think it has demonstrated actually the value of Wave 2 SPF investment. I mean, the intention of transition was to bring together a diverse network of stakeholders, and I think we've certainly seen that in these projects. And of course, as Gary has mentioned as well, communicating that to the wider public is of fundamental importance as well in the next steps when we think about audiences. Also, I sense that we have, it's a good time to reflect on where we are as a network, but I think we have landed ourselves in the right space, and thinking about that intersect between technology, choices and policy, I think is really evident. And something else that has really resonated throughout the different projects, to me certainly, are those trade-offs that we need to really think about. Evident carbon, clean air when we're thinking about transport modes and in-vehicle exposure, bus shelter design, trade-offs with other considerations as well, just as a couple of examples. So it's not straightforward. There aren't easy solutions. And I think we need to be aware that we need to work together in order to achieve those incremental gains and optimize where we can for air quality. And as you'll be aware, we're always pressing for a sort of holistic air quality approach, where we're thinking about both exposure and emissions across a whole range of different environments. I think that's strongly reflected. I also just wanted to say thank you to everyone here, and particularly to our co-investigators who've led sessions. So thank you to Francis, Felix, Charlotte, and of course James Levine, our network manager, who's coordinated today, and Katie Youngwood, who's been doing a lot behind the scenes to get us in the right rooms at the right time, etc. So thank you. And also we have some of our advisory group here. So it's a pleasure to have John Fairburn, who chairs our group, alongside other members present, and again for their input to the network as we move forwards. In terms of sort of next steps, I think all of the feedback from today is tremendously helpful, certainly in terms of thinking where we take these. Obviously, these are unpublished findings. We're really keen to make sure that they're out there. And as we discussed earlier, open data is another core principle of the network. And that's, again, part of these projects is enabling that data to be used more widely as well for other future projects. Another key output we're going to be developing is a one-page summary briefing note from each of the projects. So again, something which is suggested by advisory group is that it's really important we don't just have the academic outputs, but we also ensure we have something which we can take to stakeholders, which clearly articulates the research questions and findings. And of course, like all good research, this has generated new hypotheses as well. We are keen as a network to bring people together to explore those. And of course, we'll also have another round of discovery and innovation funding forthcoming this year as well, which will continue the work of the network. But thank you to everyone for your time today. I know it's been a intense, but certainly to me anyway, very productive and insightful, interesting meeting. And I think we will draw to a close now, but thank you. And just as a final reminder, if you do want to get in touch, email address, visit us at Transition Air, and also, of course, follow us on Twitter. You can also sign up to receive our newsletter, if not already, by contacting us. And just to flag our 2 forthcoming events as well, which will be publicised shortly. Thank you.